Hello friends, in this video we will discuss about the given problem. Demonstrate the validity of the following identities by means of truth tables. Here 5 bits they have given. For these 5 bits we should develop the truth tables and demonstrate the validity of the following identities. The first one is Demorgan's theorem for 3 variables. X plus y plus z whole dash equal to x dash y dash z dash. This is first bit. Second bit is x y z whole dash equal to x dash plus y dash plus z dash. In the truth table, here x, y, z are 3 input variables. With these 3 input variables, we should write the binary combinations 2 power 3. 2 power 3 equal to 8. So totally 8 binary combinations we can write. 8 means 0 to 7. To write the binary, we should take the binary weights as 2 power 0, 2 power 1 and 2 power 2. 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4. So based on these binary weights, we should write these binary values. For 0, 0, 0, 0, for 1, 0, 0, 1. That means we have to place ones in the corresponding positions of binary weights to get the equivalent decimal value. Okay. Now 2. 2 means in the position of 2, we have to place 1. 3 means 2 plus 1. So in these two positions, we should place ones. Similarly for 5, 6, 7. This is the output for part 1. This is the output for part 2. For output part 1, take LHS. LHS is x plus y plus z whole dash. So first we should find the x plus y plus z value. After that we should apply the complement. Therefore, x plus y plus z means r-ing of x, y and z. OR gate operation is if any one of the input is 1, the output should be 1. A, B are 2 inputs 0, 0, 0, 1, 1, 0, 1, 1. The OR operation says that when both inputs are 0, then only the output should be 0. For the remaining values, it should be 1. Based on this truth table, we should write the x plus y plus z. There are 3 inputs we are taking. Okay, therefore, when 3 inputs are 0, the output is 0. Otherwise, the output should be 1. Next, x plus y plus z whole dash means the complement of the x plus y plus z. That is just inverse. For 0, it should be 1. For the remaining all ones, all zeros. Okay, this is the LHS part. Now we have to find the value of x dash, y dash, z dash. So first we should find the x dash. X dash means complement of x. So complement of x means here 4 zeros. That means 4 ones. Next 4 ones, therefore 4 zeros. Next y dash. Y dash means complement of y. 2 zeros means 2 ones. Alternatively 2 ones, 2 zeros, 2 ones, 2 zeros. Next z dash. Complement of z. Therefore alternatively we are having ones. It is 1 0, 1 0, 1 0, 1 0. Next ANDing of x dash, y dash, z dash. AND operation means AB. AB means when both inputs are 1, then only the output will be 1. In the remaining cases, output is 0. Okay. So based on this AND operation, we should find the value of x dash, y dash, z dash. That means when all the inputs are 1, then only the output will be 1. Okay. Now we should check LHS and RHS. So both are same. Okay. That means the first Demorgan's law is verified. Now let us take the second part. In this, first find the XYZ. XYZ means AND gate operation. When all inputs are 1, then only the output is 1. Therefore, in this case only we have 1. For the remaining all values, it will be 0. XYZ whole dash. That means the complement of the XYZ. Now, all these zeros becomes as 1s. This 1 as 0. Okay. Next, RHS part. X dash, Y dash, Z dash. So, R-ing of these 3 values. Already we have found the x dash, y dash, z dash. Now R-ing of these 3 values. R-ing means if all the inputs are 0, then only the output is 0. Based on this condition, for these 3 values, only at this case we have all zeros. Okay. So for these values only, the output will be 0. The remaining values are all ones. Okay. Now we should check LHS and RHS. Both are same. Nothing but the second Demorgan's law also verified with the help of the truth table. The second bit is the distributive law x plus yz equal to x plus y into x plus z. Now in the LHS part, first we should find the yz value. Yz means ANDing of yz. Later we should find the LHS. LHS is x plus yz. That means we should concentrate only on x and yz. Plus means OR gate. Okay. Therefore 0, 0 means 0. 0, 0, 0, 0, 0, 0. 0, 1 means 1. So here 4 ones means directly we can write it as 1. Okay, x plus yz. The next RHS part. In RHS, first we should find the x plus y, next x plus z. After that we should add these two terms. So when both inputs are 0, then only the output is 0. So in these two cases we have 0. In the remaining combinations we have 1s. So that the output is 1. Next x plus z. 0, 0 means 0. Next here it is 1, 0, 0, 0, 1. Remaining all combinations 1s. Next adding of these two. So when both inputs are 1, then only the output is 1. So in all these combinations, both are 1s. Therefore, the output should be 1. In the remaining cases, the output is 0. Okay. Now we should check LHS and RHS part. So both are the same. Okay. So that the distributive law also verified with the help of the truth table. Next one. The distributive law x of y plus z equal to xy plus xz. This is the second distributive law. Here also same 3 input variables x, y, z 0, 0, 0 to 1, 1, 1. Y plus z first we should find. In this combination we have both zeros. Similarly here also 0. The remaining all should be 1s. Next x into y plus z. This is the LHS part. So x is ANDed with y plus z. AND gate means when both inputs are 1, then only the output is 1. Only in this combination we have 1s. In the RHS part, first we should find the xy. The output is 1. In these two cases only we have 1s. Next xz. These two combinations are both 1s. And these two combinations also both 1s. And at this place we have 1s. Now we should Ring these two. Now for all these combinations, both inputs are 0. So that the output is 0. In the remaining cases, at least a single one is there, so that the output should be 1. Now we should check LHS and RHS part. So both are same. That means the second distributive law also is verified with the help of truth table. The associative law. Associative law says that x plus y plus z equal to x plus y plus z. First we should solve the parenthesis part, y plus z. These two combinations only, both inputs are 0. The remaining combinations is having at least one single one. Okay. So that the output is 1. Next x plus y plus z. Now we should concentrate x into y plus z only. Okay. Ring operation again. In these two combinations, the output is 0. In the remaining all combination output should be 1. Next RHS part. X plus y first we should find because it is in parenthesis. Now x plus y means Ring of x and y. So in these two combinations, both zeros, so that the output should be 0. The remaining all combinations are 1s. Next, this is Ring with the z. When both inputs are 0, then the output is 0. In the remaining all combinations here 1s, so that the output should be 1 irrespective of the z value. LHS equal to RHS. That means the associative law is verified with the help of truth table. This is the second associative law, x of yz equal to xy of z. So first we should finish the yz part. Later it should be ANDed with the x for LHS part. So yz. Yz means ANDing. ANDing means when both inputs are 1, then only the output is 1. Okay. In these two cases we have both 1s. So the output is 1. Now x is ANDed with the yz. So x and yz only we have to consider. When both inputs are 1, then only the output is 1. Okay. In the last combination only we have both 1s. In the remaining all combinations, at least one single 0 is available. So that the output is 0. Therefore, this is the LHS part. Similarly, RHS part. RHS part is first we should find the xy, parenthesis part. Xy means ANDing of x and y. Here, in these two cases only we have both 1s. Therefore, 2 1s. The remaining all combinations should be 0 output. Next to RHS part, xy of z. That means ANDing of xy with z. Now here only at this case we have both 1s. The remaining all combinations at least one single 0 is there. So that the output should be 1 at this place only. The remaining all combinations outputs are 0. Now we should check LHS and RHS. Both are same. That means the second associative law also is verified with the help of truth table. So this is the solution for the given problem. I hope you understand this problem. Please subscribe to my channel DLT Quest. Thank you.